Hi guys, Assalamualaikum. My name is Nur Syamil Filza binti Ishaq from CS770F1. In my video, I would like to introducing IT infrastructure technology by Google DeepMind, which is Differentiable Neural Computer DNC. So, are you ready for some awesome news? So, for introduction, Google collaborate with DeepMind company to introducing the hybrid computing using a neural network with dynamic external memory, and also known as Differentiable Neural Computer (DNC). For background of company, Demis Hassabis is a Google DeepMind CEO. He said that here we introduce a machine learning model called a differentiable neural computer (DNC), which consists of a neural network that can read from and write to an external memory matrix, analog to the random access memory in a conventional computer. Like a conventional computer, it can use its memory to represent and manipulate complex data structures, but like a neural network, it can learn to do so from data. And here's some videos of the CEO of Google Mind explaining on how DNC, which is AlphaGo, used in a Go game match.
Games are kind of microcosm of the outside world. That's why games were invented. That's why humans find it fun to play. There's a rich history of computers tackling board games. It started with games like backgammon, drafts, and then finally there was Deep Blue in '97 that beat Kasparov at chess, which was obviously a huge watershed moment for game AI. Since then, the really big remaining sort of holy grail, if you like, has been Go. In chess, the number of possible moves is about 20 for the average position. In Go, it's about 200. Another way of viewing the complexity of Go is that the number of possible configurations of the board is more than the number of atoms in the universe. If you ask a great Go player why they played a particular move, sometimes they'll just tell you it felt right. So the one way you can think of it is that Go is a much more intuitive game, whereas chess is a much more logic-based game. AlphaGo is our program to actually try and crack Go. We played the European champion Fan Wei in a 5-game match. We have an estimate of how strong a program is, but of course you never know. When you play a human player, they do all sorts of very interesting creative things that your programs don't necessarily do. So there's always an unknown.
When we play the first game, I lose. Interesting.
I think he was a bit stunned after the first game, and I think he was unsure as to whether he hadn't prepared enough or whether the program was really strong.
I think after first game, maybe he don't like fight. He like play slowly, so it's why begin the second game, I fight.
Do mistakes sometimes. It's give me confidence.
I think maybe I'm right. It's why for another game I fight all the time.
This. Now it's complicated.
But I lose all my game.
AlphaGo won 5-0, which is the first time ever a program has beaten a professional player. The way I see where we are now is that we've beaten the European champion now, and the next step for us is to try and challenge the legendary player Lee Sedol.
The previous tool used is artificial neural network that are remarkable adept at sensory processing, sequence learning, and reinforcement learning. And there is a limit in their ability to represent variable and data structure and to store data over long time scale owing to the lack of external memory. And here's why DNC has been introduced as a new machine learning model. DNC, neural network that can read from and write to an external memory matrix analog to the random access memory in a convention. There are some advantages of DNC. The first advantage is DNC can successfully answer synthetic questions designed to emulate reason and inference problem in natural language. The second advantage is the computational and memory resource of artificial neural networks are mixed together in the network weak and neuron activity. The third advantage is DNCs have the capacity to solve complex structured tasks that are inaccessible to neural networks without external read-write memory. Here is software architect design pattern for deep learning architecture. Based on the figure, it illustrates of the DNC architecture. The neural network controller receives external input and based on this interact with the memory using read and write operation known as heads. To help the controller navigate the memory, DNC stores temporal link to keep track of the order things were written in and record the current usage level of each memory location. The DNC learn how to use memory and how to produce answer completely from scratch. They learn to do so using the magic of optimization. When a DNC produces an answer, they compare the answer to a desired correct answer. Over time, the controller learns to produce answers that are closer and closer to the correct answer. In the process, it figures out how to use its memory. In a family tree, they showed that it could answer questions that require complex deductions. For example, even though they only describe parent, child, and sibling relationship to the network, we could ask it questions like who is Freya's maternal great-uncles. They also found it possible to analyze how DNC used their memories by visualizing which location in memory were being read by the controller to produce what answers. Conventional neural network in our comparison either could not store the information or they could not learn to reason in a way that would generalize to new examples. This is a video of DNC tested in AlphaGo, which is AlphaGo versus Licedo in the Go match game.
I think maybe the game ended.
No, I don't think so because it looks like E is still counting.
No, I think he resigned.
Wow, I think you're right. Wow. Wow, wow, wow. Man, how could you tell there?
Well, there's a white stone in a weird place. I think he placed that stone to show he resigned.
Oh my gosh. Well,
Yeah,
congratulations to
AlphaGo.
to AlphaGo.
Yeah.
That
I think we're going to
is-
have an official announcement
Yeah, we have to
about the
right,
result.
Right. But this is just a massive.
Yeah, he's
achievement.
revising the endgame. He's showing the mistake that AlphaGo made, actually.
Right.
Showing that he gained a little bit right there. And we have a result.
There's our official result.
Yeah.
All right. Well, congratulations to AlphaGo.
Okay, this figure is an artist's impression of a DNC. The following controller network is visualized as the operator of a factory where information is delivered in the form of 0 and 1s. And then it manipulates by 3 robotic arming reading, writing, and erasing on a scroll that represent the memory. And finally, exported as a newly minted binary sequence. Thanks for watching. Bye.